A very good day to dear learners. Today I welcome you to this new session in which I'll be talking about graphical presentation of data. So far you must have seen me in this week that when we talked about organization of data, hands-on experience regarding organization of data. So today I'm going to start with how are you going to represent data graphically. So let's have an overview of this particular session. So by the end of the session, you'll be able to understand what is the objective behind graphical representation. Why do we use that in statistics or in any other discipline? And then moreover, you'll be also able to explain what are the different types of graphical representation and as well as comprehend what is the basic rule behind it, general rules of graphical representation, and what principles are we to follow for effective graphical presentations. Okay, so let's begin. So if we talk about graphical representation of data, now we have to understand, see, numerical data is so complex and it is so difficult to interpret and understand. For example, if I just show you the marks just right now on the slide, right? So for you to just visualize, just think about the marks and the frequency distribution, it will take time. It's definitely that our eyes has to accommodate with such vast amount of information. So basically, graphical representation is a form in which we are making visually we are making the data very appealing in the form of charts, diagrams, and graph. So it's converting the raw tabulated data to easy to understand picture form, right? Which also shows pattern, it also shows comparisons and different relationships as well. So graphical representation is the visual display and it is used in many academic and professional disciplines. So most widely it is being used in medicine, mathematics, sciences and social sciences. And moreover, if we also find that when we are presenting the data graphically, what it is doing, it is helping us to quantify, to sort out and present data which is understandable to a large variety of audience. No matter what the audience different learning styles are, they're able to understand by showcasing the data. Now see, this is an example I took from NCERT book. Now, if I show you this data, which is about the average monthly temperature and rainfall in Delhi. So for you, if I ask which month has the highest rainfall or which month has the highest temperature, so it will take time. It's definitely, we are humans. It will take us time to look at the data, and even the data is in decimals. So we have to understand, okay, so let me compare which month has the least amount and the highest amount. It will take time. But the moment I show you this, now what is this? The moment you see this, you're not even looking at the figure. It's just that, yes, this month has the highest rainfall or highest temperatures here. So we can see right here. And in fact, in this, both the bar graph and the line graph are simultaneously being shown, and this actually tells us that yes, two variables can also be visualized and it can be represented as well. So if you look into the objective of graphical representation, so of course, simplification. To simplify such a complex detailed data, you're reducing large scattered numerical data into a simple, meaningful form, which is understandable and which is self-explanatory, and anybody can look at it. Yes, the June has the highest rainfall and least is in Feb, right? Just by looking at the graph. Moreover, even the clarity to make data easy at a glance. So you can see like pie chart. The moment you see it, the different type of juices are given. So the consumption is more of tap water. I mean, it's so easy. So it is easy, the information is also very clearly represented. Moreover, it also helps in comparison. It enables quick comparison between groups. So graphs helps to compare different sets of data side by side. So see here, the number of line graphs, it is helping us to compare humanities with science with commerce, right? What is the pass percentage of students? So visuals, they eliminate confusions and they make patterns very clear and very visual, very appealing also. Moreover, it also tells us about trend setting. What is the trend? So the graph shows how the data is behaving over time and it highlights the growth, even if there is a rise or the decline or any kind of a seasonal variation, just like we saw in the previous graph and even in this line graph, how the rainfall is varying, right? Where it is rising, where it is highest, why is it declining, and but what is the seasonal variation? So mostly if you find, yes, in weather report, in geography, we are using this kind of trend analysis. Also in business, also, we see the rise of the demand and supply of the product as well. Then, of course, not to mention the attractiveness, how the moment that you see visuals, it's so engaging, so and makes the lesson all the more interesting. And of course, it also helps in decision making. So once you showcase the data visually, so what is happening, and the part where you are really particular about your data, it should be very well presented. It will help all the future researchers, the manager, the policymakers to basically take decision based on this particular data which has been showcased. So here, see, by looking at the population, this is the population growth over time, so over a decade, and we can see that how the countries have been arranged. So just by visualizing it, a lot of policy makers and the researchers and the business decisions can be made by looking at it. Now coming to the part where we'll be looking into the different types of graphical presentations. So first is the bar graph, which represents the rectangular bars of equal width with length, which is proportion to the values, right? And it is of course best used for comparison. So if you have even three data here, you can easily place them side by side and you can compare it just by looking at it. For example, the population in France can be easily compared with this bar graph, okay, with different colors you can show. And here, of course, types of sport is there. This is vertical bar graph and this is horizontal bar graph. You can either place it vertical or horizontal, okay. Then comes histogram. That is another type of bar graph for continuous frequency distribution. So where the class intervals are shown, and histogram is a visual, you can say, presentation used to summarize discrete or continuous data. And it shows the frequency distribution of continuous data mostly. So you see, here the intervals are there. This is the class interval or the bin also. And here, of course, there is no gaps here, and the data is arranged with equal class interval, and this shows that the different data. For example, here it is showing the salaries of employees from grade 0 to 10 to so on, $1,000, right? So this is where the data is also being showcased. Now a question should come in your mind. What is the difference between a bar graph and histogram? They both almost look alike, but yes, there is a difference. If you look at bar graph, it represents categorical data, right? So this is a bar graph, categorical data is present here, and here there is a histogram represents numerical data. It could be discrete or continuous data. So no spaces are here, spaces are here in bar graph, but no spaces will be in the histogram. And in bar graph, equal space between two consecutive bars. So even the spacing is equal, remember that, okay? And the data can be arranged in any order, right? But here the orderly arrangement is necessary. So data has to be arranged in order of the range. And x-axis can represent anything in bar graph, but here x-axis should represent only continuous data, that is in terms of numbers. Now this is the chart. Now you can see even this in this particular figure, these are the bin. Class interval is being present here, no gaps, and you have the x-axis which shows frequency, and this y-axis which is showing the frequency, and the x-axis which is showing the class intervals. So this is how a bar graph and a histogram will look like, right? Now if you move forward, there's another kind of visual representation in the form of frequency polygon. Now a line graph which is connecting the midpoints of the class interval in a frequency distribution, it helps to compare basically two distributions on the same graph, right? So you can see here, if you're comparing the midpoint, and the midpoint is attached to the x-axis, right? And this forms from 0 depending on the data that is being presented here. So you see that this is through line segments we are attaching this, and we are making it into a polygon. So frequency polygons are line graphs basically, which are representing a continuous data set's frequency distribution, and we can get it by dividing the data into intervals or bins. And It shows us basically the overall pattern, you can say, of data distribution as well. And of course, it's being used in many different fields like economics, and it is used in statistics and so on. We also find that if you look at the line graph, the advantages, what do you find? That it is very easy to interpret. Like we can see that the information is very easy to interpret, and it highlights the pattern, the trends, and it can also display a very large data set, and also it can detect any outliers, any kind of unusual data point can also be detected through this particular thing. So what is the difference between histogram and frequency polygon? So if you look at the histogram usually display data using adjacent bars. Whereas frequency polygon represents the very same data which is connected with straight lines. Okay. So histograms are mainly used for continuous data, with frequency polygon can present both continuous and discrete data. Now, if you look at the distribution shape of histogram, there it is the overall distribution shape of data. The frequency polygon, you can say that it only shows the trends and patterns across the interval. And of course, in a histogram, you can see the width, right? You can see the width of the bars, but here the class interval is not that much, it's not at all visible. It's only the midpoints that are visible. You don't know the width of the class interval. So only it is plotted in the form of points, the midpoints, and it is connected through line segments. Okay. Now let's move forward. Another visual representation is through the pie chart. Okay, this is, personally speaking, this is one of my favorite representation. It is, you can make it so colorful, and the data is so lively, it's so appealing when you look at a pie chart. So it's a circular chart which is cut into different slices, right? And of course, the thing is that here the data is presented in the form of the percentage. So it is, you can say, the weightage, or you can, that is the circular figure, which is the weightage which is given to the proportion of data. So, the angle of the entire circle is 360 degrees, right? If you look at the circle, the angle is 360 degrees, right? And which is also converted into percentage. So, for basically for 36 degrees, it would be 10 percentage. For and 3.6 degrees, it would be 1 percentage. Okay, that's how we do. And you have to, of course, calculate in percentages. When we'll do the hands-on experience, I'll tell you how to make the pie chart. So here, of course, whatever, for example, this is recommended diet, and according to the legends, the different diets are given here, and the percentage is calculated, and equally, according to the percentage, the pie chart is being distributed. So all the complete data will not exceed 360 degrees. Remember that. Okay. Now comes a line graph. So a graph that uses points to connected by lines to present any change over time. Okay, that is known as line graph. Of course, this is also showing trends and time series data. You can see here. So line graph or line chart, which are basically used to represent quantitative data, which is collected over a specific period of time. So you see the X usually has the time period. Okay. And any quantity that is measured is on the y-axis. And the line graph actually gives the clear picture of anything that is declining, anything that is being increasing. So a simple line graph would be in the form that you see here, right? Here. And right. So this is a simple line graph which is showing you the produced sales. Okay. Then after the simple line graph, we have the compound, the multiple line graph in the form of more than 2 that you can see in this figure. And then comes this is the multiple line graph, and this is the compound line graph. So the more the data that is presented on a line graph, you can easily see, like for example, like drought. Here 4 conditions, in fact 5 conditions are given of drought here in this by different colors also. So you see how appealing it is, that how the line graph, it shows trends and time series also, and it is easily comparable as well. Okay. Now coming to cumulative frequency curve, which is also known as ogive, right? So a line graph, it shows basically the cumulative frequency. Now once we'll do the hands-on experience, you will be able to calculate the cumulative frequency. I think we did that also, and how we're going to plot on that, that will be in my subsequent lecture. So a graphical representation of cumulative distribution is called ogive, which is a curve, right? So here it is joined by a free hand. So basically it also helps to find the median, it also helps to find the quartile and even the percentile through this particular data. So if you look into the cumulative frequency ogive, it is a line graph that plots cumulative frequency showing the number of data points that are below a certain value, and typically it's the upper boundary of a class interval. And a cumulative frequency polygon, if you remember, is also a line graph of cumulative frequency, but it is constructed using the midpoints of the class, and the connecting points are formed with the line segments. So there we find that the only difference is that the cumulative frequency polygon is connected by line segment, and but the curve is by through a free hand. So it's basically a very smooth curve. Next, now the next type of representation is through pictogram. Now, pictogram is a very interesting and very simplest, I should say, the form of visual and data representation. Okay, so here the pictures are being sent in the form of icons or symbols to represent the data, and they are arranged in a single line or a grid, and each line represents some kind of a unit. It could be usually 1, 10, 1, 10 or 100. And they are also known as pictograph, icon charts, picture charts, and picture unit chart. Okay, so basically what it is doing, pictogram, if you look at it, the whole purpose of pictogram is that it wants to make the data visualization more memorable. It helps in the retention, so, and it is best for visual memory. And the purpose behind pictogram is that any boring facts, any boring data can become very compelling, very appealing as well. And let me tell you another fascinating fact about pictogram. It's not that pictogram has been introduced like just few years from now, like with the advent of science. But if you look at long ago, when the whole information in the early times had to be recorded, so thousands and thousands of years ago, I should say, even in the civilization of Egyptian or Sumerians, we did find pictures that were basically engraved on the walls of the cave, hieroglyphics, right? And those symbol based scriptures were able to communicate the information, anything, any record event, any trade record, even to tell the stories, they use that kind of a pictogram. But pictogram, it gained, you can say, popularity somewhere around 1964 when the Tokyo Olympics were organized. That was the first time that they started using pictogram, in a public sphere. They started using a visual language instead of words. So now pictogram is used what? You must have seen, at the fire exits, no smoking signs, for transportation, any place you're traveling, the restroom, baggage claim, departure gate, and things like that. Even in the public spaces, the recycling, the quiet zone, and the disabled washrooms, or so you can say washroom for physically challenged people, right? So all that symbols, and through symbols, they're basically telling us that yes, that this is a form of a pictogram. Now, rules for drawing a graphical representation. There are certain rules that you have to follow. First, select the right graph type. You have to always match the graph with the nature of your data. So you use bar graph or pie chart for categorical data like gender, occupation, and subject. And if you're using line graphs or histograms, you're supposed to use the continuous data. Okay, here, like height, rainfall, and temperature. Then you have to provide a clear title. Title tells you exactly what the data represents. So graph 1, just instead of writing just graph 1 or figure 1, you have to tell this is the average rainfall in Delhi and the time span from 2015 to 2020. Then, of course, labeling axes with units, that's important. Remember in your school times when you did not write your the units and how your marks were deducted because of that. So it's very important. If you were writing that y-axis, x-axis in years, y-axis of rainfall, which is in millimeters. Okay, So this is important that you have to write in the unit as well. Then choose an appropriate scale. This is very important. How are you representing your data on the class interval? So if, for example, if the student's range is from 20 to 95, so you select setting the y-axis from 0 to 100, it makes a comparison realistic. But the more minutely you try to narrow your scale down, so it even the slightest difference will appear too large. So this is important. How the scale that you're selecting, that should be also appropriate. Then ensure neatness and readability. That means the whole data should be very clean, very neatly drawn, so it can be easily represented. And of course, legend should be there. Now, what is a legend? So legend in a graph is a key which identifies what are the different data series that is being presented here with different colors or patterns or symbols. Now, see, if you look at the data here, you know that these are the avenues produced in different regions, but like central, mid-Atlantic and so on. But what is this red? What is this blue? You have to represent, you have to give that data here also. So this is where the legend will come. That means blue is books, red is electronics, movies and music. So legend should be very clear. Then acknowledge the data source. Source is very important. Even, for example, this, I have produced this figure for your understanding, right? So, but here I also mentioned the source where I got the figure from. So, even when you're presenting or you're writing an assignment, presenting a data, source is important. That once you present pie chart or bar graph, write the source that you took this data from the Ministry of Education or the Government of India, and mention the year as well in which the data had been published. Now, what are the general rules for graphical data? Now we look into it. First is the do's. What are you supposed to do? So, like I said, use appropriate graph type, okay, according to the data set that you have. And then maintain clarity and simplicity. Use proper scales, equal intervals starting from 0 if possible, right? Label axis, we just have seen that titles, legends, units, everything should be very accurate. And you have to ensure accuracy proportion in the pie chart as well. The bar length must be very correct, okay? Now, what are the don'ts that you have to be particular about when you're presenting a data? Don't overload the data with too much information. You don't want that. It beats the purpose, right? And don't use misleading scales as well. So here I would say the misleading in the sense that you're showing that, for example, like just like I said, if you're using too narrow a class interval, so even the slightest difference would seem that the difference is very large. The sales have doubled, but in fact they have not. But the kind of scale that you've selected, that is giving the misleading information. And don't mix inconsistent data as well, right? So the kind of data that you want to present, it should be in continuation with the information that you want to show. So don't use percentage along with absolute numbers and so on. Then coming to don't leave graphs without labels and legends, right? So you should tell, like if it's a literacy rates of male and female, that should be very clearly labeled, right? Don't distort by using 3D effects unnecessarily, because what happens is that because if you use the 3D effect, one slice of the pie chart, for example, may appear simply big because of the viewing angle in which that you have portrayed the 3D effect, which can also mislead the audience about its proportion. So be careful regarding that. Now let's look at the general principle of graphical presentation. So in the general, the bar graph the bar graph papers that you have attached to your files and everything, which is basically having these cells. So they help us, to plot the graph accurately. So whenever there's a graphical representation, there is always two reference line, the coordinate axis, right? The horizontal, which is known as the x-axis. Here, this is the x-axis. And the vertical, that is the y-axis. This is the x-axis and this is the y-axis, right? So, of course, and when we start, the axis intersect at a point. This is the intersecting point. So, all the values of the x-axis which are to the right of the origin, that means here, they will be positive, and here to the left of the origin would be negative. And for the y-axis, the values above would be positive and values below the intersection point would be negative. And that actually, the intersection of these two lines, the intersection of the two lines divides it into 4 quadrants. You have quadrant 1, 2, 3 and 4. So if you have any data that you want to plot, for example, if you want to plot 2 and 3, right, points 2 and 3, so of course 2 is here and this is 3. So both are positive. So it will be in quadrant 1. If it is -2 and -3, -2 here and -3 here. So this is where we find that this is in the third quadrant. This is the point, right, here. So similarly, any information that you want to plot here, all you have to do is just trace the line first from the x, then from the y, see where does it intersect. If it is, for example, if I tell 4 and -4 or 4 and -3, right? 4 and -3. So what do you do? From 4, you trace a line, -3 is here, and this is the point, right? So it is lying in the fourth quadrant. So this way you'll be able to plot and represent, and you'll be following the general principle of graphical representation. Use a graph paper initially, and once you have the hands-on experience, then of course you can use any kind of paper if you know how to, equally justify the axis and the information present on the both the axes. Okay. So this is all. So if all about today's graphical representation. So to conclude, you must have had a clear understanding of the objective, types, and what are the guiding principles of graphical representation, which is enabling effective communication of data. So you see, by selecting appropriate graph type and you're following some essential rules, so information can really become visually very appealing, very accurate, and easy to interpret. And we need that. We need all these qualities. Why? Because we want to make the analysis meaningful and reach a proper decision regarding the graphical representation, right? So with this, I've completed today's lecture on graphical representation, and next lecture will be hands-on experience. So be prepared. We're going to work together and we're going to prepare different beautiful, appealing graphs that we have just seen today, and we'll have hands-on experience regarding that. So these are the different references that you can go through for any comprehensive reading that you want to have about the statistics and the graphical representation. So thank you so much for your patience listening. I hope you had a nice time, and I'll be seeing you again in my next lecture. Till then, take care of yourself. Bye-bye.